Okay, so this week 15, and this quarter is totally 16 weeks. So only 2 weeks, only one more week. So before the break. Okay, so we review the scientific notation in the homework. So right now we move to the term. Actually, this term we just given a different name here. Actually, very close to exponent. It's exactly exponent, right? Exponent part we focus on what? We focus on say with say x the power, right? This is the exponent, and if there's only one variable, and their power rule, right? We talk about this part, and their division rule, quotient rule, right? We'll talk about this one. And what about others? Fraction rule, right? No, other than that, this one, what are we rule talking about? Called if there's two different factors, different variables, their power rules, each of the factor power by itself, right? If they are fractions, each the numerator and denominator power by itself, right? And we also have talked about their zero rules. If x not equal 0, any number except 0, their power 0, the result will be 1, right? And we also talk about negative rules. This one can be changed into here, right? Right. So this one most focus on that part, exponents. So right now we extend it a little bit further, as you call terms. Actually, look, terms we extend it to the exponent part. Actually, we did it already. So term, actually they have something like this. They have additional coefficient in front of the exponent, right? In part. So let's this is actually real number. This is coefficient. So this part, this is coefficient, right? And this is the base. This is the base. So this is the exponent. Exponent. So they made of this. This is a term. This is a term. And sometimes just like multiple variables, ym. So that's two variables. So we still consider this one is coefficient. But right now we have two base, right? Two different base and two different exponents. So this is still a term. All right, this term. So in this kind of case, let's one word need to bring up is called degree. Degree. What degree is here? Degree, we consider this exponent if in this only one variable in the term, in these kinds of term, we call this is term, all right? This is term. And the degree is the exponent itself. All right, so let me give a quick example. Say 5x squared. So this is second 2 degree, all right? So degree is 2. Degree is 2. Is this one. We consider this is degree 2. If let's just say 5x, the degree is only 1. All right, here is 1. Come from here. So the exponent here consider is the degree. And the coefficient For this one, definitely is 5, right? For this one, also coefficient is 5. But what about this one? Say 2xy. 2xy. So the coefficient is 2, right? What about degree? The degree of this one is a little bit different than one variable. Because of less two variable, the degree of the x is 1. Degree of y is 1. So this degree is actually the sum of the variables, the sum of the exponent of each variable. So it means one come here, the degree here is 2. Okay, so if I say 3x squared y, what's the degree of this one? Come from here, 2, and it has 1 here. So degree is 3 degree. The coefficient is 3 here, right? The coefficient comes from here. Or maybe I already talked about from next slide, so I should go to next slide. Examples. So the term. Oh, yes, I talked too quick here. Actually, term here. Let me move this one. So the term. So this is not a good example, actually. I don't think this has, just go back to what I said here. So, so if a term actually is come from exponent. So ax n, again, this is coefficient, this is a degree, this is the base. If less multi variables, the degree for this one here is n, and for this one is the sum of each of the exponent. The coefficient definitely is the top, the front part here. All right, so let's see more examples. Say -3x squared. I come from here. So the coefficient is -3, right? -3. The degree is 2, right? All right. So what about is the multi? There's 3 variables. So x power 3, y, z. Right? There are 3 variables here. So the coefficient is 5. Right? Coefficient is 5. What about the degree? The degree is 3. This is 1. This is 1. So 3 plus 1 and 1. So your degree is 5. Right? What about give a constant number? That's no variables. No variable, most time it actually come from like this, time 1. So we didn't write this out, right? This is a constant number. The coefficient is 2. The degree, just like I said, x power 0. So degree is 0. Okay, the degree of 0. What about here? What about here? Someone say, what about x? What about this one? This one we write into what? We write into like this. So what's the degree of this one? We talk this a little bit later. We don't talk about the degree is negative part. We didn't talk about negative part, right? So actually this one will be right into like this. We didn't talk about this degree is 2. But actually degree is -2. Coefficient is 2, right? Degree is -2. Coefficient is come here too. So well understanding, right? So degree actually come from exponent. If less multi variables like this x, y, there are some of them. If there are 3 of the variables, sum of all of them, right? So here became 5. If there are constant number, the degree is 0. Any constant numbers, degree is 0. Right? It's negative number, the degree is negative. But most time we focus on the positive part first, all right? Okay, so here, give a term. Give a terms. We find their variables, try to find their degrees, and try to find the coefficient. All right. Okay. So with introduction, these kinds of basic concept about terms. So since we know the terms, so anyone can give you a term, give you a terms. Okay, so give you say 3, what I'm choosing. So say 3x squared. So this is term. What about 5x 3? This is another term, right? So the degree of this term is 2. The degree of this term is 3. So when I do addition, do they combine together? No, right? No, not easy, because of their exponent here is different. We say the degree is different, right? But if let's say 3x squared plus 8x squared, collate addition together, I believe you guys already know here is yes, they can combine together. Why? Just like we did the scientific notation part. Because of this part is the same, right? This part is the same. Just like here, say 3 times x squared, here is 8 times x squared. This part, this is like a 3 times this one, 8 times this one. This is like a factor, 3 in x squared, 8 times x squared. So this is one of the factor of these numbers. So they can combine together, right? This part don't changing. The rest part is only coefficient part do it together. So you can go to 11, right? Just like what we right now doing 3.5 times 10 times here and 6.1. Can they combine? They cannot direct combine. So you need to adjust to make sure this part is the same, right? So we do the adjust. What do we adjust? We make it here became 10 power 2, 0.61. Did you see last homework? What are we doing? Oh. So right now this part is the same, right? So you can do addition. So we can do addition is this part, the common part, take it out. The rest part is do the addition, right? Right? So we need to make sure this part is the same. This part is the same. So like they are common factor. Like they are common factor. Right? Common factor. So we bring together here. So rest only just this coefficient part do the addition. So this means this part, if they are this part the same, we call this is called like term. Only different is coefficient part. Coefficient part, they can be same, they can be different, but the rest part is exactly the same. They are variable the same, their exponent the same. So they are variable the same, their exponent part is the same. So the degree the same. So we consider like terms. So right now we introducing like terms. What is like term? So AXN, BXN. They are variable. This is called base. Variable, the base, the same. Their exponent part also the same. So when they do addition, this part, we call this term and this term called like terms. Like term. Only different is only coefficient is different. Or maybe they are sometimes maybe the same as we still consider like terms. Like terms is means the variable is the same, the exponent is the same. All right. Okay. So when they do additions, the only coefficient part do the addition, right? When I do minus, only coefficient part do the calculation, do the operation. The rest part we didn't do anything, right? So just like earlier, actually we do a lot. So 3x plus 2x. You can see here is the common one, right? So we easily got 5x. Why we get 5? Because of this is the common factor, right? Common factor x take it out, so 3 plus 2. So actually this 2 is the like term. So they can get combined together. So only the coefficient part do the addition. The rest part we don't need to do any changing. Okay, so let me give this some example here. So you can see, all right, so let's give some another one example here. Says negatives, and let me use different color for each adjust. So let's see example here, new example. 6x squared y. Second one, 2x squared y. Is there like terms? Is it there like terms or not? First, we judge like term or not. It's based on, first we judge their variable, right? We need a variable is the same or not. They should be the same. They should be the same. Their degree, each of the variable exponent should be exactly the same, right? So let's see here. So x, in this part, their exponent is exactly the same, right? For another variable y, their exponent both are 1. So they are exactly the same. So we can consider these two are like terms. So when they do addition, so you can quickly get a what? Got is negative 6 plus 2. You got a negative 4x squared y, right? So the rest one's not changing, only coefficient bar do the operation, right? Right? Okay, so let's see another example. Say A, B, C. Another one is AB squared C. So let me add one here. So is these two like term or not? First, see the A. The A here, yes, their variable is the same, the exponent the same. See the B, the variable the same, but the exponent is different, right? Here is 1, here is 2. So this 2 is not like terms, right? Because of this variable and this variable, they are different. I mean, the variable is the same, exponent is different. Even C is the same, exponent the same. One of them is different, they would be different. So these two, when you do the addition, you cannot just do the coefficient part addition because they are not like terms. So they cannot be combined together. Right? So we need to define like terms. We try to define like terms. They are variably the same. The exponent should be exactly the same. Only different, may different is the coefficient part. So when you combine like terms, when you do the combine like terms, only could do is do the coefficient part, do the calculation, right? So let's see this easy example, a quick example. See these examples. We do this often already, right? So okay, so let's firstly let's see what's this one. So 3x squared minus x minus this one. Firstly, we get rid of the parentheses first. We use the distributive methods, right? 3x squared minus x squared minus 3x and plus x. First, we need to find like terms. How to find like terms? like term, they are variable the same, the degree is the same. I mean, the exponent of each variable is the same. So we can see here, everyone have the same variables, right? Second, we find the degree the same. Degree the same. For this part, the degree here is 2. Here is 1. So they are different, right? So here is 2. So looks like here is the like terms, right? And here, this one, and this one, and this term are the same or like terms. So for the like terms, you definitely everyone can eat. Oh, that's so easy. So right now this part is the same. We put them together. All right. So the rest part, this is easy for everyone, right? So you can go to here is 2x squared. Y got 2, 2 minus 1, but this one don't change it, right? What about this part? This part is x is the same. So -1 plus 3 plus 1. So you got a 3, right? Because of this 3 is like term. They are variable the same. Their exponent is also the same. Only different is coefficient. The coefficient part is -1 plus 3 plus 1. So you got back 3, right? So actually, after combine like terms, you simplify this algebraic expression. So just like they're saying here, to combine like terms, the numerical coefficient and multiply the result by common variable factors. Common, what a common variable factor? So they are variable the same, their degree the same. All right. So sometimes people are a little bit confusing. I know last time I teach some, I didn't explain. It looks like I explained some a little bit better, but I probably someone didn't explain. I didn't understand so well. So let's see some more examples. See this example. All right. So 6abc squared and 6ab squared. So firstly, my question is, this 2 is like term or not like term? Not like term, right? Why? Firstly, you can see the variable a 1, here also 1. B, you have B variable as well. But here is 1, here is 2. They are different. They already different, right? Because of this one have 2 variable, this or 2 variable, degree is different. They are not exactly the same. Other than coefficient, their rest not exactly the same. Other than say that when this is the third variable, but here don't have it. Definitely they are different. They are not like term. They are not like term. They are not like terms, right? Let's see more example. Say 7y, 3z. They are not like term. Their variable is different already. So when they do addition, you definitely cannot do any combinations, right? They are not like terms. Only like terms can do the combinations. Only like term can do the combinations. All right. Let me ask another question. 2x squared y, 3yx squared. Is there like term or not? Write your question, write answers on the chat part or on the white screen. They are like term or not? Can you guys write it in the chat part? Max, is there like term or not? Max. Jalen, Is it like term or not? This two is like term or not like term? Iris, please unmute yourself. Answer the question.
I think they're not like terms.
They're not. Okay. Iris saying it's not like term. Angie. Anna.
I think they are like terms.
Like terms or not like terms? Okay. Max, you didn't answer yet. Jalen, you didn't answer yet. Suri.
Can I change my answer? I looked again and I think they're like terms.
Like terms. Okay. Okay, let's see here. Okay, see this one. See these two terms. So the question, first, just like question, we try to judge like term or not like term actually based on, we see the variable is the same or not, right? Second one, to see their exponent part is exactly the same or not. But I didn't say their sequence. Like from the difference, you can see here, actually here, xy, their sequence is different. But based on our previously called commutative methods, this term can be rewrite, right? You can rewrite here, say 3x squared y, right? Doesn't matter. This factor y in front or back, it doesn't matter, right? So actually, you can see these two. Let's rewrite this part so you can easily judge they are like term or not like term. They are variable the same, the exponent the same. This second variable they are same, second exponent also the same. So other than the coefficient part, the rest part is the same. So they are like terms, right? They are like terms. When they do the addition, they can rewrite it into, say, 5x squared y, right? The common part is keep the same. When do the operation, when do the addition and minus, only the coefficient part do the calculation, right? So most important here is, say, this one can be rewrite into 3x squared y, right? So they are like terms, but this is definitely different. Even you adjust the places, they are still different. Like here, their exponent is different. They are definitely different. They are not like terms. They are already different. The definitely is not like term. But like this one, after proper adjustment, you can see the rest, other than coefficient, the rest part is the same. They are like terms. So, okay, so we talked about terms and like terms, and combine like term actually is there when they do addition and subtraction. Only like term they can combine together, right? All right, so let's go move on some more detailed examples. So we'll make our more familiar in these kinds of things. All right. Before I move on that one, I have some additional. I think we talked about this one already. I think I duplicate some of the work here. For the terms, before I move to the like term, I should go to find some like term example here. Let me see if I have like term example here. Yes. All right, see this one. See something if we combine like term or like combine like terms. So first, when we do some terms, combine like terms, we need to find like terms before we do the like term, combine like terms. So see this example. See this example. This is actually a lot of terms, right? These are three terms. they do say add least term, least polynomial terms. Actually, before I talk about, actually, I need introducing a little bit, but disregard this part. Just say combine like terms. So actually, you can see this expression made three terms. Three terms. So multi terms in this expression. Multi terms. These three terms we call trinomial. We also call polynomial. Actually, call three terms. You can see this is one term. This is one term. This is another term, right? And let's say add this two. This is three term, is three term. We call polynomial terms, three term. When they do the addition, how you simplify it? When you do these kinds of simplification, you needed to find like terms. Only like terms can combine together. So what do we need to do is find out like term. So see this one. So you can see all the variable is x. Here variable is x. Here variable is x. Here is nothing. Here is nothing. Right? So here is constant number. Second, we find the exponent. Here exponent is 2. Here is 1. Here is 2. Here is 1. Here is 2. So you can see, let me use green color. Use different color to find out their like term. So this is x squared here, right? Here is x squared here. So they are like terms. And for this part, this is only x, right? Exponent is 1. This is only x, exponent is 1. And these two is like terms, right? And the last one, here is constant number. Here is constant number. Constant number definitely can combine, right? So when they do, you try to simplify this. So you can get what? So you can go what? These like terms you can combine together. So it became negative 4x squared, right? Because of this part is the same. The rest part you can put together. When do this part like this one like term, so it became 6x, right? 5 plus 1 here, x was common. And the last one, this is like terms, both of them are constant number, right? The degree is 1. So you can got it. You can got a negative plus 2, right? So you can see this kind of, that's when they have a multi terms, when you try to simplify it, we need to find the like term first, and then simplify it, right? Right. See more example here. So this is the expression. Let's also have three terms: 7y squared cubic, 2y squared plus 7. Second one is 6y squared plus 1. Let's say add these two. Add these two. So you can see, firstly, we find which one is the like term. You can see here is y cubic. So we find the rest y, this is not cubic. Y, there's no y here. It's y squared. It's y cubic. So this is one only alone. There's no like term in this expression. So this one you can copy down first, right? All right, see second one. Second one here. This is negative 2y squared. Y squared. This is not y squared. This is y squared as well, right? So these two is like terms. Because of other than coefficient, the rest is y squared, the rest is the same, right? So you can combine them together, became positive y squared, right? The last one, constant number, right? So you can get an 8. So you can see combine like terms. Like this one, you didn't find like terms. You have leave it alone by itself, just copy down. So these two is like terms. You can add them together, do the addition. The coefficient part do the addition. And the constant number, they are also considered like terms. They can combine together, right? So I think this one is relatively easy, but just needed to keep in mind like the typical question, typical like terms, like what I earlier mentioned about like 3x squared y and 2yx squared. This sometimes you need a judgment to judge these kinds of case. Sometimes need a proper change. So make sure and not misjudge, okay? If they are like term or not. So actually today we just talked about very basic part here. Term. This term actually come made of the variables, coefficient, and their degrees. Actually here base is the variable part, right? Also we talked about like terms. How to identify if there are two terms is like term or not. If there are two like terms, how to combine them? Combining only do the coefficient part, right? Calculation. The rest didn't do. Actually, is the addition subtraction. So combine like terms is addition subtraction. Only do the coefficient part to work. About the multiply and division part, we talk about in the exponent area. Actually, the week before last week, the homework is actually related to this part. We have say ax y time bxy. I mean, give you any two terms when they do time together, the coefficient time together, right? And the same variable, the exponent part, you do the addition. And second, and same variable like y here, the rest of the exponent do the addition, right? When I do the divide, very close to what we learn in the exponent part. So let's pause here. So we left this one for next quarter. I mean, for next year, polynomial. We will talk this more details because of this super critical for algebra. So let's pause here today, and I will send out some homework a little bit later. So do you guys have any questions? If not, you can see you next week. We didn't spend some time to review each of the topic, but I hopefully you guys can use homework. Go back, check homework, especially do the long ones. And we will quiz. Most of quiz actually is come out our homework. All right. All right. See you next week.
Thank you. Bye.
Okay. See you next week. Have a wonderful week.